Part 4: The Deep Learning Big Bang.
It really feels like modern AI just appeared out of thin air, right? One minute we're all talking about clunky robots, and the next, bam, tools like ChatGPT are everywhere, changing everything. But that explosion, that overnight success, it wasn't an accident. It was the result of this one critical decade where finally all the pieces just fell into place. So let's rewind the clock and find the exact moment that fuse was lit.
It all comes down to this number, 15.3%. Back in 2012, this wasn't just some random statistic. This was the starting gun for the entire AI revolution. It represented a change so big, so fundamental, it would reshape our world. So, what on earth does it actually mean?
Well, that was the error rate for a new system called AlexNet in a huge image recognition contest. Now, to get why this is such a big deal, you have to look at the competition. The very best systems before 2012, they were stuck. They had an error rate of around 26%. AlexNet didn't just beat that score, it absolutely shattered it, dropping all the way to 15.3%. That's a leap of over 10 percentage points. This wasn't just a small step forward, this was a revolution. And that moment, right there, became what we now call the Big Bang of deep learning. It was the point where decades of quiet, sometimes frustrating, research suddenly came together and just exploded into the mainstream. It proved that this new way of thinking about AI wasn't just another idea. It was overwhelmingly better. So what was the secret sauce? How to do it? Well, all the older systems were built by humans who painstakingly wrote rules for everything. If it has pointy ears and whiskers and a tail, then it might be a cat. AlexNet was totally different. It was a deep neural network. You didn't program it with rules, you just showed it millions of pictures. And from all that data, it taught itself how to see. It wasn't just following instructions, it had learned. But that brings up a big question. Why 2012? Why didn't this happen in, say, 1992 or 2002? The thing is, the Big Bang wasn't just one single discovery. It was more like a perfect storm. The moment when three absolutely crucial ingredients finally came together at the exact same time.
This whole revolution was built on three pillars, and you really needed all three. You needed the raw muscle of new computer chips, you needed the massive fuel of data from the internet, and you needed the smart new algorithms that could finally put it all to work.
Okay, let's break that down. First, the hardware. Turns out the graphics cards, GPUs, that were being built for video games were a perfect fit for the math AI needed. So all of a sudden, a $500 gaming card could do the work of a supercomputer from just a few years earlier. Second, you need data. A lot of data. These neural networks are hungry, and the internet basically became an all-you-can-eat buffet. Datasets like ImageNet had millions and millions of labeled images just ready to go. And finally, a few really clever software tricks, new algorithms, solved some old, nagging problems that had held these networks back for years. Take away any one of those, and 2012 just doesn't happen. You needed all three.
And here's the wild part. Unlike a lot of older AI research that stayed locked up in labs for years, this stuff moved fast. The same basic technology that won that contest in 2012 started popping up in the products you and I use, almost immediately.
Ever wonder how Siri or Alexa suddenly got so much better at understanding you? Or how Facebook or Google Photos can find every picture of your dog without you ever tagging them? And those Netflix recommendations that are just a little too perfect? Yep, all of that is a direct line from the deep learning breakthrough of 2012.
Okay, so AI could see and hear better than ever. The perception problem was getting solved. But the next question was a big one. Could it think? Could it go beyond just recognizing patterns and tackle something that requires strategy, creativity, something that feels more like human intuition? The ultimate test for that would be the ancient, impossibly complex game of Go.
So, fast forward to 2016. Google's AI, called AlphaGo, is facing off against Lee Sedol, the world champion. And then it happens. The AI makes move 37. It was a move that was so bizarre, so alien to 2,500 years of human strategy that the expert commentators were just speechless. They were sure the machine had glitched. They thought it was just a dumb, amateur mistake.
But it wasn't a mistake. Not even close. It was pure genius. Move 37 completely changed the course of the game, and AlphaGo went on to win the whole match. And here's the mind-blowing part. The AI didn't just copy the best human players. It went beyond them. It discovered strategies that no human had even thought of in over 2,000 years. The intuition barrier? Consider it shattered.
So this leap from just seeing things to having this kind of intuition, well, it brought in billions of dollars in investment and pushed progress into overdrive. But this rapidly expanding universe of AI power also created a whole new set of really complex, really tricky problems that we suddenly had to face. For one thing, it kicked off a massive hardware arms race. I mean, think about it. AlexNet in 2012 trained on just 2 gaming GPUs for a week. By 2020, the cutting-edge models needed thousands of custom-built chips running nonstop for months, costing millions and millions of dollars. Progress was now tied to having access to just immense computing power. And as these AI systems started getting used out in the real world, another huge problem popped up: bias. See, if you train an AI on data from our world, it also learns all of our world's biases and flaws. This created a massive new challenge. How do you build an AI that's actually fair for everyone? At the same time, facial recognition went from science fiction to reality. On one hand, it gave us some incredible new tools, but on the other, it kicked off this huge global debate about a really tough question. How do you balance security and convenience with a person's fundamental right to privacy? And of course, as the technology got better, military applications became a very real possibility. And that posed maybe the most profound challenge of all. How do you even begin to design the rules for an autonomous machine that could find itself in a life or death situation? Then, in 2017, came the next monster breakthrough. It was a completely new AI design called the Transformer. Before this, AI kind of read a sentence word by word, like a little kid sounding things out. And it would often lose the meaning of the whole sentence. But Transformers, they could see the entire sentence all at once and understand how every single word related to every other word. It was the difference between reading a ransom note cut out from magazines and reading a beautiful novel. This was the key that finally unlocked true language understanding. And that brings us pretty much to the end of the decade. By 2021, all of those pieces we've been talking about, the powerful hardware, the endless data, the smart algorithms, the billions in investment, they were all finally in place, setting the stage for an even bigger explosion to come. So let's just recap where things stood. You had these massive transformer models like GPT-3 that were getting incredibly powerful. You had cloud computing that made all that hardware accessible to way more people. You had more data than ever before and more money flooding into the field than at any point in history. The rocket was on the launch pad. The fuel tanks were full. The countdown had already begun. So when you look at it this way, you realize that the overnight success of today's AI was anything but. It was built brick by brick, breakthrough by breakthrough, over an entire decade. And that leaves us with one final really important question for today. The experts spent 10 years building these incredibly powerful foundations. Now that tools like ChatGPT have basically handed the blueprints to everyone, what happens next?